We're going to look at a quick lesson in geometric sequences and series. We'll start by looking at the definition of a sequence. A geometric sequence is a sequence of non-zero numbers where each term after the first term is found by multiplying the previous number by a non-zero number called the common ratio. So we'll start with any number and we keep multiplying it by a fixed ratio, which we call a common ratio. So in this case, I have a sequence where each term is multiplied by 8. So 2 times 4 is 8, 8 times 4 is 32, and 32 times 4 is 128. The common ratio in this case is 4. Here's another example where the terms actually get smaller because they are multiplied by a number smaller than 1. So 24 times a half would be 12, 12 times a half would be 6, 6 times 1/2 is 3. So the common ratio is 1/2. And here's another example where our sequence alternates between a positive 3 and a negative 3, which means the common ratio is -1. 3 times -1 would be -3, and if I keep multiplying by a -1, the ratio keeps alternating. In general, we say the nth term of a geometric sequence with initial term a sub 0 and a common ratio r can be given by the formula a sub n. So the nth term is the initial term multiplied by the common ratio to the power of n minus 1. Notice the power is n minus 1 because the very first term did not to be multiplied by anything. And then after the first term, we keep multiplying by the common ratio of r. So if we go back and look at the example we had started with, 2, 8, 32, 128, our first term is 2. The common ratio was 4. So we can write that formula as a sub n equals 2 times 4 to the n minus 1. And just to check, let's say I want to find the third term of this sequence, and just to make sure our formula works, the third term of this sequence would have been 2 times 4 to the 3 minus 1. That would be 2 times 4 squared, or 2 times 16, and 2 times 16 is 32. And as we can see, the third term of the sequence was 32. Next, we're going to look at what we call a geometric series. So a series in general is what I get when I add the terms of a sequence or a progression together. So a geometric series, the sum of the numbers in a geometric progression, right? So if I go back and look at the 4 terms that I had in my sequence earlier, 2, 8, 32, 128, and add them together, I get 170. So that's a partial sum of the first 4 terms of that sequence, right? So as a formula, I can find that if I have 4 terms or 5 terms or 20 terms that I want to find the sum of, as long as it's a geometric sequence, I can find the first k terms using this formula. So s sub k, that's the notation we use for the sum of the first k terms, is my a sub 0, my initial term, times 1 minus my common ratio to the kth power over 1 minus r. Or if we adopt the summation notation, the sigma notation, recall that the sigma means add, and I start with n equals 1 and add it all the way to the kth term. That's the same formula, right? So just different notation for writing s sub k. So again, go back to the sequence that I had, 2, 8, 32, 128, and let's say I want to find the first 4 terms using the formula. This is how it would look like. So I would start with my initial term 2, 1 minus 4 to the 4th, right? I'm finding the sum of the first 4 terms. So this 4 up there is the number of terms I'm adding. The other 4 is my common ratio. So 2 times 1 minus 4 to the 4th over 1 minus 4. And if I work that out, 4 to the 4th is 256. 1 minus 256 multiplied by 2 gives me negative 510. In the denominator, I have 1 minus 4, which is negative 3. 510 divided by negative 3 is 170, which is the same number we got the other way. Now, if I'm adding 4 terms, it may be just easier for me to just find them and add them. But if I'm adding 20 terms of a sequence, a partial sum of the first 20 terms, then it definitely would pay off to use this formula, right? And to continue, now what if I want to add an infinite number of terms? So my sequence keeps on going, and I don't want to stop after 4 terms or 6 terms. Now, if we look at the sequence we were already looking at and consider that as a series of terms added, so 2 plus 8 plus 32 plus 128, and I keep writing the rest of the terms, we'll notice that it's going to keep getting bigger and bigger and bigger, and adding them clearly will give me an infinite number, right? So that number is going to continue growing, and I keep adding more and more to it. We say that series diverges. But if my series was getting smaller, it would be possible to get a sum, right? So if it gets bigger, it clearly is going to become infinite. It turns out that a geometric series, as long as it gets smaller, actually has a finite sum. So, and if I add an infinite geometric series, it will converge to a number if and only if the absolute value of the common ratio is less than 1. That means my sequence keeps getting smaller, right? So if r is smaller than 1, I keep multiplying by a number that's less than 1. These numbers are going to keep getting smaller. Now we say the absolute value is less than 1 because I could multiply by a negative number or by a positive number as long as the absolute value of that negative or positive number is smaller than 1. And then this formula, a over 1 minus r, would let me find the sum of the infinite series, right? So either writing it as s sub infinity, or more commonly, again, in this case, we use the sigma notation starting from 1 all the way to infinity, adding up all the terms of a geometric sequence. We get a over 1 minus. So let's look at one more example. In this case, I have a sequence 54, 36, 24, 16, and we want to find the sum of the first 8 terms and then eventually find the sum of all the terms. Let's first verify that it is a geometric sequence. Whether it is or not doesn't prevent me from finding the first 8 terms. As long as I can find what the pattern is, I can write the first 8 terms and add them. To be able to find the sum of all the terms, I do need to make sure it's a geometric sequence, so I can go ahead and use the formula we were given. So let's see if this is a geometric sequence or not. So for it to be a geometric sequence, I gotta make sure that the ratio between all the terms are the same. So if I go and try the first 2 terms and divide them by each other, so 36 over 54, and these are both divisible by 18, so I can reduce this and I get 2/3. And just to verify, make sure that is a common ratio, means it stays the same throughout the sequence. 24 over 36, those are reducible by 12. I would get 2/3. And finally, 16 over 24, those are reducible by 8. I get 2/3. So it is a geometric sequence. All the terms are multiplied by 2/3. So I can actually go ahead and write it as a geometric sequence. A sub n would be my first term, which is 54, multiplied by my common ratio, which is 2/3 to the n minus 1. Right? So that would be the formula for our geometric sequence. But to find the sum of the first 8 terms, if you recall, the formula would require me to take my first term, which is 54, multiply it by 1 minus my common ratio, in this case 2/3, taken to the 8th power, because I'm finding the sum of the first 8 terms, and then divide that by 1 minus r, so, or 1 minus 2/3. Okay, so the rest of it is kind of a matter of doing a little bit of arithmetic and working this out. So if I go ahead and simplify this, on the top I have 54 times 1 minus 2/3 to the 8th power. 2 to the 8 is 256. 3 to the 8 is 6,561. And on the bottom, I have 1 minus 2/3. If I find a common denominator within my parentheses and combine my terms, I'm going to get 6,305 over 6,561. On the bottom, 1 minus 2/3 is 1/3. Now, if I, again, combine what I have on the top and multiply by the reciprocal of the denominator, I am going to end up with 12,610 over 81. Or if I write it as a mixed number, that's 155 and 55 over 81. Okay, so if I wrote all the 8 terms and kept writing the next 4 and added them all together, that's the answer I would get. Now, the next question is find the sum of all the terms if it exists. Now, remember, it is a geometric sequence, but I can only find the sum of all the terms if r is less than 1, or absolute value of r is less than 1. In this case, it is true that absolute value of 2/3 is less than 1. So I can go ahead and find the sum of the terms, and if you recall, that formula was a over 1 minus r. So in this case, 54 over 1 minus 2/3. That is 54 over 1/3, or 54 times 3. If I multiply by the reciprocal, that gives me 162. So if I took all the terms and kept adding them all the way to infinity, I would end up with 162. So that was a quick review of how the geometric sequences in series work. We're going to use that quite a bit throughout the semester.